Hello everybody, today we are going to talk about the one of famous motor in the world. It is about induction motor. We're going to learn about the physical construction component. Also we will learn about the principle of functioning of that motor. So now we're going to talk about the composition of the induction motor. We have a stator. This is the bobine of our stator. The composition of that metallic part and the bobine, we call it stator, is the fixed part of the induction motor. We have also the second part, our rotor. We can see here our rotor has a shaft. It also has a shield. We have a front one and we have the back one. Also, in motor of induction motor, we have a fan. There is a fan here. This fan is helping our motor to make it cold, because as we know, like induction one is when it has electric, we become hot. The heat can make our motor to burn. So the fan is connected to the shaft. One is working, is making our motor cold. So also, just we need to know that the form of this metallic is also to help our motor to produce less heat, so it can protect our motor from the damage of heating and something like that. So now we are going to talk about the function of that motor. We also talk about the connection of our induction motor. So here we have the stator. As I said, the stator has bobine. Those bobine must be connected to the source. In the source we receive 3 phases. I think this one is not working. So we are receiving 3 phases. So those 3 bobines must be connected to the source in the way to have an EMF, to have a magnetics inside to be able to turn our machine. So about like when we connect this first bobine to U2, another one to U1. The second bobine we connect it to V1 and V2. The third one also to W1 to W2. In this way our motor will start to turn, and then our rotor is inside this stator, so it will also take the EMF from the stator, so it can produce the movement like our magnetic field will create, so our rotor will turn. So in this motor is related to Lenz's law. As we know that when a current is passing through a bobine, is producing a magnetic force, EMF we call it. So when we put also another bobine near the bobine who has electric, we produce here voltage in the output. So the motor of induction is also following the same law. Here with our inductance, we have electric. Electric is creating here inside. We have a magnetic EMF, and our rotor through this surface is also connected with that bobine, is creating a rotation, so our motor will work. So now I'm going to talk about the type of connection inside induction motor with 3 phases. As we know that in our induction motor we have 3 bobines. So here I represent the 3 bobines with different connections. We have delta connection, we have also star connection. So with delta connection, we know that the line voltage is equal to the voltage to the bobine, is the same. But the difference with the star voltages is like the line voltages is different than the voltage between the bobine. Why? Because here we have, for example, U1, V1, V2, but the output of the bobine is connected together in one point. We call it node, where there is 0 voltages. That's why VB is the voltage the voltage between the bobine equal to square root of 3 times VL. But with our bobine, with our delta connection, we know that VL equal to VB, because here, for example, we have U1, V1, W2. The same voltages, if our power has is producing us a constant voltages, U1, V2 is like a line voltages, is gonna be the same with the bobine voltages for all those stuff. But for the current here is different. As we know that with KCL, Kirchhoff law, is this current, it will be separate in two parts. Definitely EL is different with EB. EB is the current inside the bobine. So the current inside the bobine for delta connection is square root of 3 times EL. But here for the delta connection, EL is equal to EB, because the line current is the same with the line inside the current inside the bobine. So that is about the connection of induction motor, 3 phases. So now I'm going to talk about the slip inside induction motor with 3 phases. As we know that in our starter, here we have the EMF produced by the starter. So it's giving us here like 2 knots electromagnetic. So since the rotor also is inside the starter, it also be influenced, I can say, by the EMF of the starter. You also start to turn. So we can see that those two, rotor and starter, will not reach, because since the starter start to turn the first, the rotor story will start to follow the EMF from the starter. So sometimes when the starter is turned, it can stop. We have the EMF from the rotor can be reached together. In that period, we have the sleep. The rotor will make small like a sound. We can see now it is sleep, and then it can also start the process. So in this way we talk about the sleep for those who don't know how we used to have the sleep inside induction motor, 3 phases. So to produce the torque inside induction motor with 3 phases, we know that when this machine is connected to the source, we have a power. So the power in the output with the speed of our motor will help us to have the torque. So we can say that we know that the power is equal to torque times the speed. So to produce the torque, we have power over speed. So in this way we have the torque, like we can say in short, the torque is proportional to the so the torque is proportional to the power and speed. So now we're going to talk about the direction of the rotation. We know that when we connect U1, V1, W2 to our bobine in input, we have, for example, this sense of the rotation inside the bobine, because this one is representing the bobine inside our motor. So if we want to have a different sense, like we want the motor to turn in this direction, what we need to do, we're gonna touch the input of the voltages. Like here, we need just to change. We put, for example, the V1 go to alignment our line, and V2 is here. So when we change the input voltages, here also we have a different direction in our motor, the differential of rotation. So many people can ask, how how can we control the speed inside the induction motor? To control the speed inside the induction motor, there is many parameters we can change, like voltages. We can change like the frequency, or we can change also the pole during the construction if you want to change the speed of our motor. So what about the cosine phi? We call it also power factor. So for example, we know that in all induction materials we have active power, like there is the cosine phi inside. So we know that apparent power we represent it by S equal by V times E. So the cosine phi, like we can say the cosine phi is equal to P over S. And we know that more in this case we know that more we are consuming, for example, the active power, more also I can show you in this direction. For example, here we have P, here we have S. So more we are consuming the active power, more also we are gonna use the apparent power. This is good for us, for users, for example, but for people used to generate electric is a problem for them. That's why they need to introduce the reactance power. The reactance power will help us to reduce the apparent power, as I was saying. So we have this construction. Here we have power, here we have key due to reactance inside our bobine, and here we have S. So I think in short we can understand about the cosine phi, how we used to obtain it inside the motor. So we can ask ourselves how we used to obtain the efficiency inside the motor of induction of 3 phases. So as we know at the beginning, I said the motor has 2 main parts, stator and rotor. Like in the stator we have the power in. Power in is power giving to our stator. But that power, we have some losses inside due to hysteresis current or focus current, due to heat. Like there is one formula which says that P, like the power, lost power due to resistance inside the stator is equal to E squared times R. This formula is available for many type, all type of induction motor. So here, as I say, we have some losses due to hysteresis current, Foucault current. So in that side, here we have PTR. PTR is the power of transmission, the power who's gonna transmit to the rotor side. Also in the rotor we have some losses inside our rotor. So when we take the power in minus power due to the Foucault current minus the power, like losses in the rotor, we will have the power out. So to find the efficiency of our motor, we're gonna take power out of the motor divided by power in. The power is introducing by the motor. So in this way we have the efficiency of our motor. It means more we have losses inside our motor, more we have less power in the output, so our efficiency will be bad. So we need to construct our motor in a way that we reduce losses in the stator part, even in the rotor part, so we have a good efficiency and inside our motor of induction. So in short, we can say that induction motor is more useful in nowadays because we can find this motor for using for pulley, for compressor. We can also use induction for a motor even to the nuclear power plant to many devices in the world that are using this induction motor because it has more efficiency, more capacity to do many work. Thank you for listening.